This question comes from Bay Area JavaScript interview meetup on August 16th. Given a directed graph, find the total number of routes to reach the destination from a given source that the path have exactly m edges. Assuming our source is 0, so we go from here, we want to reach 3. The number of edges, it just means the number of steps we need to take in order to reach there, or how many hops we need to make. So if we hop to 1, 5, 2, 3, so you're hopping 4 times. So this is a valid route, all right? You must hop 4 times or 4 edges. Another valid case is 0, 1, 6, 5, 3, right? Then you also have 0, 6, 5, 2, 3. Some of the invalid cases are 0, 1, 2, 3. Now, because you only hop 3 times, 3 is not 4, so it's not valid. 0, 1, 5, 4, because it is directed graph, 4 cannot go to 3, so this is also invalid. Another test case is source is 0, destination is 4, take 4 times. Now you have 0, 1, 2, 3, 4. Now I already show you the valid path. This is the graph data structure. It has a key, which is the integer. For example, this key will be 0, and the adjacent will be in the form of array, where you also store other fellow nodes. So in the case of 0, you will store the node of 1 and 6, right? Now you have 8 nodes. Now from 0, you push 1 and 6. So 0 push 1 and 6. For example, let's take 5, for example, you push 2, 3, 4, okay? So 5, you push 2, 3, 4. Now your function will take in a source. Function will take in a source, a destination, and a number of edges, where the source is a node data structure, destination is a node data structure, the number of edges is a number. So node, and a number, all right? So the first answer will be 3, second will be 4. I'll position the screen nicely. I don't know about you, but for me, I immediately think of backtracking. Backtracking is a recursion and is also depth-first search. You can also do breadth-first search, but I think backtracking is more intuitive, so I'm going to share my intuition with you. Now, backtracking involves 3 concepts: a choice, a constraint, and a goal. The choice is what node to visit next. The constraint is maximum number of hops. The goal is when we reach the end of the hop, we reach the destination. How do we make the choice? We can loop through the array, right? Now, what is the constraint? If our current hop is the same, once we reach the number of edges or maximum hops, we return. What is our goal? Our result will plus if we reach the destination. So let us code it out. Our result will be 0 and return result. We have a helper function called backtracking and call it. We can put in the source and the current number of edges. So when you start, the current hop is obviously 0. Okay, so we do the constraint first. If the current hop is the same as the number of edges, we return. However, let's first evaluate, have we reached the goal? So you can do res plus plus, res plus equal to, if the current node dot key is the same as destination dot key. So mission accomplished. Now here we can make the choice. Node dot adjacent dot for each. So you are looping through the neighbors or adjacent array. E stands for element, meaning each neighbor. Every neighbor you will do a backtracking, where you pass in the neighbor and current hop +1, right? Because every time you make a hop, your hop number increment by 1. Okay, let's see what we got. 3 and 4, looks like it works. Now I missed out something, is that a node can only be visited once. Now if I add a self edge here, let me add that my node 3 at this line. My node 3 can visit the node itself, and we run it again, we get 6, 4. The reason being, originally your answer is 3. Now the reason being, it opened up the possibility for other path to be a valid route. For example, 0, 1, 5, 3. Originally it only has 3, so it wasn't valid. But because I added h here, so it become valid. Another one is 0, 1, 2, 3. So it originally is 3, now it's 4, so it's valid. Then you also have 0, 6, 5, 3, right? So there are 3 more possibilities. But because we cannot visit these 3 more than once, so we need to clean it up. We can clean it up by using a hash table. Call it scene. Now, what you need to do is, once you have seen it, once you see node key, we continue, right? Now from here, you need to first seen it, then unseen it. Oh, this is return. 3, 4. So that fixed the bug.